Hello good people, I'm going to talk about polyatomic ions. So far, all of the other ions I have mentioned are monoatomic ions. This simply means that they were made up of a single atom. For example, a chlorine atom became a chloride anion. It turns out that we can have ions that are made up of more than one atom. These are known as polyatomic ions. Poly means many. In this video, I'm going to look at a few common polyatomic ions. So let me bring in a table. In green, I have polyatomic anions, and in purple, I have a polyatomic cation. The first polyatomic ion on this list has a formula of OH-, so it is made up of an oxygen atom and a hydrogen atom, and the overall charge is 1 negative. The name of this polyatomic ion is hydroxide. The next one has a formula of CO3, 2-, indicating that it is made up of a single carbon atom and 3 oxygen atoms. Overall, the charge is 2 negative. The name of this ion is carbonate. Next one is NO2-, indicating that it is made up of a single nitrogen atom and 2 oxygen atoms. The overall charge is 1 negative. The name of the ion is nitrite. The next ion is very similar. It is made up of a single nitrogen, 3 oxygens, and has an overall charge of 1 negative. The name is nitrate. The next polyatomic ion on this list is SO3, 2-, indicating that it is made up of a single sulfur, 3 oxygens, and the overall charge is 2 negative. The name of this ion is sulfite. Next ion is very similar. It is made up of a single sulfur, 4 oxygens, and has an overall charge of 2 negative. The name of this ion is sulfate. The last polyatomic anion on this list is PO4, 3-, indicating that it is made up of a single phosphorus and 4 oxygen atoms. The overall charge is 3 negative. The name of this ion is phosphate. The final polyatomic ion is in fact a cation. It has a formula of NH4+, indicating that it is made up of a single nitrogen and 4 hydrogens. The overall charge is 1 positive, and the name of this ion is ammonium. Polyatomic ions combine in much the same way as monoatomic ions to give ionic compounds. So let me take a look at a few examples I prepared earlier. If I have a sodium cation and a hydroxide anion, they will give me sodium hydroxide. What will be the formula? Just like before, I'm going to use the crossover method, which means I will have a single sodium because the charge of the hydroxide is 1, and I will have a single hydroxide ion because the charge of the sodium is 1 as well. If I combine a magnesium cation and a hydroxide anion, I will end up with magnesium hydroxide. Using the crossover method, the formula will be Mg1 and then in brackets OH2. The reason I'm putting the hydroxide in brackets is because I'm trying to indicate that there will be 2 hydroxides. Down here on the left, I'm going to combine a potassium cation and a carbonate anion. That will give me potassium carbonate. The formula will be K2, because the charge on the carbonate is 2-, and then CO3. The charge on the potassium is 1, so I will only have 1 carbonate ion. Over here on the right, I have aluminium and carbonate. This will give me aluminium carbonate. Using the crossover method, the formula will be Al for aluminium, 2, because the charge of the carbonate is 2 negative, CO3 in brackets 3, because the charge of the aluminium is 3. Note again that I am using the brackets around the carbonate to indicate that I have 3 of those. Let me look at a few more. Now I'm going to combine an ammonium cation with a chloride anion, and that will give me ammonium chloride. According to the crossover method, the formula will be NH4Cl. I have only one ammonium because the charge of the chloride is 1 negative, and I have only one chloride because the charge of the ammonium is 1 positive. In the next instance, I'm combining ammonium with sulfide. That will give me ammonium sulfide. The formula will be NH4 and then in brackets 2, because the charge of the sulfide anion is 2. And then S. And I will only have one S because the charge of the ammonium cation is 1 positive. Please note that we are now using a couple of very similar words. We have sulfide, which is SO2 negative. Then we have sulfite, which is SO3 2 negative, and sulfate, which is SO4 2 negative. So far I have been combining polyatomic ions with monoatomic ions. But we can actually combine polyatomic ions as well. So let me bring in 2 examples. In the first instance, I'm going to combine ammonium with hydroxide, and that will give me ammonium hydroxide. Using the crossover method, the formula is NH4OH. 1 ammonium and 1 hydroxide, because the charges on the ammonium and hydroxide are 1 and 1 respectively. In the last scenario, I have ammonium and phosphate. This will give me ammonium phosphate. Using the crossover method, the formula will be NH4 in brackets 3, because the charge on the phosphate ion is 3 negative. And then PO4. I only have 1 phosphate because the charge of the ammonium is 1 positive. Keep in mind that the polyatomic ions that I have shown here are not the only ones. There are others. But these 8 are the most common ones. When we write names of ionic compounds that contain polyatomic ions, we follow the same rules as before. We give the cation first and the anion second. And we use the crossover method to determine the ratio in which the ions combine. That is all for now, and I will see you on the flip side.